PostgreSQL is a powerful open-source object relational database system. It has more than 15 years of active development and proven architecture that has earned it a strong reputation for reliability, data integrity, and correctness. One of the most common tasks when you work with a database is to query data from tables by using select statement. Let's examine the select statement in more detail. First, specify a select list that can be a column or a list of columns from which you want to retrieve data. If you specify a list of columns, you need to place a comma between them. If you want to select data from all the columns, you can use an asterisk instead of specifying all column names. Second, specify the name of the table from which you want to get data after the from keyword. Notice that we added a semicolon at the end of select statement. The semicolon is not part of SQL statement. It's used to signal Postgres the end of statement. Suppose you want to know the first name, last name, and email of customers. You can specify these column names in the select clause as shown in the following query. In the second example, we use an asterisk, which is shorthand for all columns. However, it's not a good practice to use asterisks in select statement when you use them in application code like Python, Java, PHP, due to the following reason. First is database performance. Suppose you have a table with many columns and a lot of data. The select statement with the asterisk will select data from all the columns, which may not be necessary to the application. And second is application performance. Retrieving unnecessary data from the database increases the traffic between the database server and application server. In consequence, your applications may be slower to respond and less scalable. The following example uses the select statement to return full names and emails for all customers. In this example, we use the concatenation operator to concatenate the first name, space, and last name of every customer. The next example uses the select statement with an expression. It omits the from clause. The select statement returns all rows in a table. To select rows that satisfy a specified condition, you can use where clause. The where clause appears right after the from clause. It uses the condition to filter the rows returned. The condition must evaluate to true, false, or unknown. It can be a combination of Boolean expressions using AND and OR operators. Only row that calls the condition evaluates to true will be included in the result set. Besides the select statement, you can use the where clause in the update and delete statements. To form the condition, you use comparison and logical operators. The following statement selects customers whose first names are Jamie. The next example finds customers whose first name and last name are Jamie and Reese. If you want to match a string with any string in a list, you can use the in operator. For example, the second statement returns customers whose first name is one of the listed. This example finds customers whose first name starts with Bra and last names are not Motley. A relational database consists of multiple related tables. A table consists of rows and columns. Tables allow you to store structured data like customers, products, employees, etc. To create a new table, you use the create table statement. The following image illustrates the basic syntax of the create table statement. In this syntax, first, specify the name of the table after create table keywords. Second, creating a table that already exists will result in error. The if not exist option allows you to create the new table only if it doesn't exist. Third, specify a comma-separated list of table columns. Each column consists of column name, kind of data that column stores, the length of data, and column constraint. The column constraint specifies rule that data must follow. The column constraints include not null, unique, primary key, check, foreign key. Finally, specify the table constraints, including primary key, foreign key, and check. Not null ensures that value in column cannot be null. Unique ensures the value in column unique across the rows within the same table. Primary key uniquely identify rows in a table. A table can have one and only one primary key. The primary key constraint allows you to define the primary key of a table. Check ensures the data must satisfy a Boolean expression. Foreign key ensures value in a column or a group of columns exists in column or a group of columns in another table. Unlike the primary key, a table can have many foreign key. The statement on slide creates the accounts table. It has the following columns: user ID, its primary key; username, unique and not null; password, not null; email, unique and not null; created on, not null; and last login. In Postgres, a sequence is a special kind of database object that generates a sequence of integers. A sequence is often used as the primary key column in a table. By assigning the serial pseudotype to the ID column, Postgres performs the following. First, create a sequence object and set the next value generated by the sequence as a default value for the column. Second, add not null constraint to the ID column, because a sequence always generates an integer which is non-null value. Third, assign the owner of the sequence to the ID column. As a result, the sequence object is deleted when the ID column or table is dropped. Postgres provides three serial pseudotypes: small serial, serial, and big serial. It's important to know that serial doesn't implicitly create an index on the column, or make the column as a primary key. However, this can be done easily by specifying the primary key constraint for the serial column. The Postgres insert statement allows you to insert a new row into a table. The following image illustrates the most basic syntax of the insert statement. In this syntax, first specify the name of the table after insert into keyword. Second, supply a list of comma-separated values in parentheses after the value keyword. The columns and values must be in the same order. The insert statement also has an optional returning clause that returns the information of the inserted row. If you want to return the entire inserted row, you can use the asterisk. The statement on the slide inserts a new row into the links table. The update statement allows you to modify data in a table. The slide illustrates the syntax of update statement. First, specify the name of the table after the update keyword. Second, specify columns and their new values after set keyword. The columns that do not appear in the set clause retain their original values. Third, determine which rows to update in the condition of where clause. The where clause is optional. If you omit it, the update statement will update all rows in the table. The update statement has an optional returning clause that returns the updated rows. The following statement updates the course with ID 3. It changes the published date from null to defined date. Delete statement allows you to delete one or more rows from a table. The following image shows basic syntax of delete statement. First, specify the name of the table after delete from keywords. Second, use condition in where clause to specify which rows from the table to delete. The where clause is optional too. If you omit it, the delete statement will delete all rows in the table.